Welcome, loves, to the first lesson of the backend section. We're going to start and implement all the stuff that we need for our WebSocket backend part. We're going to build the structure of the project, and I will use some hints for me. So first of all, we are going to create, let us make the Python package in case of we need the init.py to register it through the project to make imports much more useful, because we're going to look up to this folder as the root folder for our Python project. Let us create the main file. Let us make it just simple and plain. Okay, we made a base app folder. Let us create initial folder for Dockerfile, which we're gonna use for Python. So in the main folder, for me it's backend folder, let's us create docker-compose file. Right reminder that you have to prepare the Docker compose and Docker components before starting this lesson. So in the Docker compose, we're going to start to create the components which we are going to use in our project. For us, they are database and web application itself, which will run in the Python for us. So let us create the services namespace and call our Python application web. Container name, we are going to use the, for example, WebSocket. Let us call it WebSocket app directly. And make build. So we're going to build our current folder, that stands for dot, all the folder inside the container, and using the Dockerfile, which will be located in our Docker folder, Python folder inside, and let us call it Dockerfile. For this moment, let us create the structure. So we're adding a directory in the Docker folder, writing down Python, and adding file Dockerfile without any extension. Yeah. Our next step is setting the command which will run our application. For fastapi applications, mostly this is the uvicorn, which goes through our folder app, main, we'll call it an app, and set the host of it. So for example, basically this is the local main host, and set it as reload. This flag will give us ability to hot reload our application if we're going to change something in our code base. It's pretty useful for development. But remember, do not use it in the production. So let us say that our volumes are this current folder, which stands by dot. We will put inside our Docker API core. So that means we will get our current folder and all the files inside and put it inside our Docker container file system, inside the war, 3 Ws, and API core. Okay, next step, to expose the ports which we're going to use. So we're going to use 8000 and inside and outside. Let us set the environment file, because we need to store our secrets in the file which will not be registered by Git. It's pretty important. So we're saying that our file, which is located inside current folder and named env. So let us create it. In addition, the best practice for it is duplicate this file to env example, where you will have your keys, but you will not have your values for those keys, your secrets actually. So in that case, you may have ability to register your env example, and other developers will understand which keys are you using and what they need to put inside. So we're setting the env file and saying that it depends on db, which is not created yet. We're going to create it after the web service in our Dockerfile. So we're going now to create the db in addition to our web application service. We're creating the DB, and it will has container name WebSocket-DB. You may call it by yourself, however you want, but I'm trying to call them like with some kind of prefixes for each project to make them human readable. And we're going to use the image of Postgres 15.0 Alpine. So Docker will download the needed resource and image to its container and run it locally, without any needs to install it manually on your computer. Let us set that it will restart on failure. Let us provide the ports. So it will be 52 and 31 to 52 and 31. And we are going to expose this port from inside to the local computer. This is important if we're gonna need to connect to the Docker container database from the outer computer system. It will maybe be used when we are going to make the migrations outside the container or something else. This is not necessary because they are connected to the local network. Well, will be connected to the local network, but inside the Docker container. Let us set env file also, and it will use the env here. And to connect them between each other, let us provide the networks, which will say that our network is WebSocket network. It's also pretty custom, and let us connect the web application to it by the same key networks and the same value. So for working these networks, let us provide the volume for DB. Say the driver is local, so it's going to store data locally, and networks, which we mentioned and wrote here, WebSocket network and driver bridge, so they will have ability to connect to each other. Please do not forget to add the empty link at the end of your file in case of Git prefers this style. It's kind of old-fashioned, but this is the good practice. So we finished our services, and in case of there is nothing to run yet, so now we are going to create the Dockerfile content for our web application. Let us say from Python 3.12 Alpine. Alpine is a lightweight version of our Python. It's only with the main libraries inside, so it will be pretty enough for us. Let us set that the work there of this is for 3W API core, as we mentioned before, to copy our volume. Set the environment variable Python don't write code 1, and another variable Python unbuffered. Copy the requirements, which we will have requirements. Copy requirements into this work gear folder of our project inside, and run the command pip install upgrade pip and /pip install no cache here -r requirements.txt, and copy all the project inside after finishing this process. So by the logic, our Docker Compose on build will run the Dockerfile, which will install all dependencies and copy all data from our current folder inside the Docker container, which is pretty enough for us. Now let us create the requirements.txt for this project. Requirements.txt, which will install our dependencies. Small cut. So those libraries we will need to use in this current project, I will provide the requirements file down below in the description section, so you may copy it and put inside your project. They may be a little bit outdated for the current moment, but if you need latest, you may just update those versions. After installing the project, we will have to use our environment. I'm using the standard PyCharm environment venv to install all our dependencies locally. We'll need that to help linter to work correctly with our libraries. And of course, we will need that to set Alembic up. The Alembic is a system for our migrations, so let us just prepare the folder for it. So let us say that Alembic init inside our current folder. Error, the following arguments are requirement directory. Yep, let us call Alembic init inside the folder Alembic. So we're initting the Alembic folder. We have now the versions, the place where we're gonna store our migrations. We have the Alembic ini, where we will need to provide the actual place and the row to our database. And this is pretty enough for the start. In the end, I want to add some gitignore file to ignore some files that we will not going to upload to Git. This is the env idea of my IDE. We made all the preparations, created the project, set up all the folders, such as an application folder for our main code, the Alembic folder, and initialized the Alembic for our migrations, Python, Dockerfile, docker-compose, which will compose it for us, and requirements, which we're going to install. Let us build the Docker, and in the next lesson, we're going to start our application. Docker-compose build. Now it's downloading all needed information, all needed libraries inside our Docker containers. So, as we can see here, we have the trouble with asyncpg, which is, according to internet, is not compatible with the CPython for Python 3 and 12. In that case, I just can to decrease the version of the Python, because it's not a big deal. Let us say that we're gonna build it on 3.11 and 1. On the real production, if you strictly need 3 and 12, of course there's need to be some investigation for solving this problem. But as a lesson, I suppose it will be pretty enough. Let us build it again. And now it builds successfully. So let us see. Is there any containers inside? No, of course, because we didn't run them. Docker compose up -p, so without displaying anything. And we're going to have the error response from the WebSocket application in case of we do not have any main app inside. So we have just a plain main file. We'll fix that in a future lesson. Let us check the Docker again. We're now having the backend and WebSocket-db and WebSocket application. So for this lesson, I suppose it's pretty enough. In the next lessons, we are going to make migrations, fill the database with the needed data, and fix problem that WebSocket application is not running. Until then.